Hi Math C students, here are a couple more examples of using the angle sum or difference formulas to evaluate sine and cosine of some new angles. Again, whenever you see an angle that's something pi over 12 and it doesn't reduce, that's when you're going to know that you should be using the angle sum or difference formulas. So for sine of 19 pi over 12, there's really like a bunch of ways you could break it up. One way to write it would be sine of, I'm going to do it as, so it's actually not going to work to do 2 pi over 12 plus 17 pi over 12 because 17 over 12 doesn't reduce. So instead, I'm going to try the next thing. I'm going to try 3 pi over 12 plus 16 pi over 12. And that totally, those both reduce. You could also do 4 pi over 12 plus 15 pi over 12. Both of those would reduce as well. So you just have to pick two fractions that are both going to reduce and add up to what you had. So this is sine of pi over 4 plus, let's see, both of those have a factor of 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. So that's how I'm going to write that. And then that's going to be sine of the first angle times cosine of the second angle plus, and then you change the order so it's cosine of the first angle times sine of the second angle. So sine of pi over 4 is root 2 over 2. Cosine of 4 pi over 3, so pi over 3 is reference angle, that means cosine is 1/2, but it's negative because the angle is in the third quadrant, so it's a negative 1/2. And then cosine of pi over 4 is root 2 over 2. And sine of 4 pi over 3, well, cosine of 4 pi over 3 is negative 1/2, so sine of 4 pi over 3 is going to be something root 3 over 2. It is going to be negative root 3 over 2 because we are in the third quadrant. So we end up with a negative root 2 over 4 minus a root 6 over 4. You can either write this as one fraction. Well, you should always write this as one fraction. Again, they're always going to be something with root 2 plus something with root 6. So write this as one as minus root 2 minus root 6 all over 4. Or you can write it as minus out in front root 2 plus root 6 all over 4. If you write the minus out in front, it's being distributed to both terms. The one way you cannot write this one is as negative root 2 minus root 6 all over 4. Because if you write the negative out in front of the fraction, it's implied that it distributes, and then it would really be negative root 2 plus root 6, which is not what we got. So be careful with that negative out in front. Let's try cosine 1. So for cosine of 23 pi over 12, one way to break this up would be cosine of, I always just start with the smallest piece I can break up. So I'm going to try pulling off a 2 pi over 12. And I'm left with 21 pi over 12. Do both of those reduce? Yes, they do. 2 pi over 12 reduces to pi over 6. 21 pi over 12, I can divide out a 3 from each of those and get 7 pi over 4. One thing to recognize, whenever you're doing these problems with an angle sum or difference formula kind of thing, and you're doing a something pi over 12, it's always going to break up into two angles. One of the angles is going to have pi over 4 or a reference angle of pi over 4, and the other angle is either going to have pi over 6 or pi over 3 or a reference angle with pi over 6 or pi over 3. Always, always, always going to happen that way. So then we use the cosine formula. It's going to be cosine of the angle times cosine of the other angle. And then for cosine, the signs are opposite. So if it's a plus here, it's a minus there. And then it's sine of the angles. Sine of the first angle times sine of the second angle. So here I end up with, let's see, cosine of pi over 6 is root 3 over 2, and that's actually correct. Cosine of 7 pi over 4, that's in quadrant 4, so we are positive root 2 over 2. Sine of pi over 6 is going to be 1/2. And sine 7 pi over 4 is going to be negative root 2 over 2. Because again, we're in quadrant 4, and we know the sign is negative. So I end up with root 3 times root 2 is root 6 over 2 times 2 is 4. Minus a minus is plus. 1 times root 2 is root 2. 2 times 2 is 4. So I end up with root 6 plus root 2 all over 4. So all of these answers have a root 6 and a root 2 on top, and it's either root 6 plus root 2, root 6 minus root 2, root 2 minus root 6, or negative root 2 minus root 6, right? There's only kind of 4 combinations root 6 is positive or negative, root 2 is positive or negative, and then it's always divided by 4. So all of these angle sum problems always look like plus or minus root 6, plus or minus root 2, all divided by 4.